Hello and welcome to this BitifEye tutorial. In this tutorial, we will show you the usage of our HDMI AWG frame generator software, which includes HDMI 1.4, 2.0, and 2.1 features and functionalities. It is a debug tool used to test the physical layer of HDMI 1.4, 2.0, and 2.1. In this tutorial, our focus is on HDMI 2.1. First, we connect ourselves to the instruments. We have the choice between two different setups of the M8195A, either with two modules or with one module. Single module means we can connect all HDMI lanes using one M8195A module. Two module means we can connect two lanes per module. In this tutorial, we will focus on the two module setup. This is required to perform the compliance tests. However, as this is a debug tool, we can also use single module in order to do some debug testing with the DUT. In order to connect to M8195A module, we need to enter an IP address which should be in this format. Similarly, for the second M8195A module, we have to enter the IP address. As we are using two modules, we need a synchronization module, namely M8197A, which provides the clock to the two M8195A modules. Clicking on the Show Connection button, a connection diagram will appear explaining how to connect to the instrument lanes are connected with the M8195A setup. In addition, we also need to connect 5 volts or an I2C or a low-speed communication controller in order to communicate with the DUT. Once we are completed, we press OK. Then connect. Press Apply HDMI setting and close. Remember, this video covers HDMI 2.1 only, so we will stick to FRL, the fixed rate link mode. We check this box and see all the information related to the HDMI 2.1 FRL. In the video mode drop-down menu, we have different FRL rates as per HDMI 2.1 specification. Based on the FRL rate we select, the link training pattern selection will automatically change. The big advantage of performing the link training manually is that we can retrieve detailed information regarding for the link training. Here in the status flags, we will see all the information from the DUT. The link training pattern requested by the DUT for lane 0, 1, 2 and 3 can be retrieved here. Based on this information, we can change the link training pattern in the main window. And after that, we have to press the Apply Selected Patterns button. Once the link training is successful, the DUT will request to switch from link training pattern to the test mode pattern. When we apply the test pattern, we can see if the DUT is performing accordingly. The pass and fail mechanism is based on character error detection that we can see as part of SCDC controller software. Our DUT is now in test mode. An alternative to the manual link training is the auto FLT. With this, the link training will be performed automatically. It can be found on the main screen. Let us walk quickly through the other functions. Additional features will appear if user click on Instrument Parameter Setup. It is available only after the frame generator is connected to the instruments. Here we have Data Amplitude, which controls the output of the AWG. The user can specify the intra or the inter-pair skew for any lane in UI plus picosecond format. Inter-pair skew will be the skew of the selected lane with respect to all the other lanes. Another option in this dialog box is Filter. Auto-configure will compose the transition time and the worst cable model according to HDMI 2.1 specifications. We have an option to enable the crosstalk as well. One of the most important components of physical layer testing is to apply jitter. We can apply the data jitter in the form of sinusoidal jitter. Additional jitter components are random jitter and ISI. Once all these parameters are set up in the window, we click Apply All Settings. All these settings, including jitter, worst cable model, crosstalk, amplitude, intra and interpair skew, will be applied on the waveform. Hope we were able to give you an idea about our HDMI AWG frame generator debug software.